Rojan. Today in New Jersey State's coming off a match. We have team 4215 Hypnotic Robotics. Now, if you guys want to get started introducing yourselves.
My name is Subham Kumar.
My name is David Soon.
Your intake has been pretty amazing. It's able to pick up samples, variant specimens very efficiently, and it's really helped reduce your amount of cycle times. So if you want to talk a little about what's special about this and how you made it happen, because I see you guys have your servo-driven connections, and this looks a little bit interesting. This looks interesting right here. Without further ado, let's get right into it.
Yeah, so this year at the beginning of the season, we had two options. We had either a pivot or a transfer system. Since last year, we decided to keep it very simple with linear slides. We decided that we would have the most optimal experience if we just decided to rig these 3 Axon Max servos. And as you see here, what's special about this is that 2 of these servos are used for the 4-bar mechanism here. So that controls that. And what this middle servo does is it allows us to have another degree of freedom here to have a lot of room for picking up different specimens, different samples in different locations on the field.
So before we had a point in the middle where it was like kind of sloped like that, but then you could only grab from in the sample. But with this flat surface, the sample can be anywhere here. As long as the entire body of the sample is like anywhere within here, the claws can grab it because they can open really wide. And so this allows us to grab with like a huge amount of like freedom.
Awesome, yeah. Now let's go on to your outtake here. It's counter spring, and you guys actually deployed in less than 0.5 seconds. I was noticing. You want to talk about a little bit how you actually made that happen?
Yeah, so this is like one of the most unique parts of our robot. So the way this counter springing works is we have constant force springs. If you try to do continuous counter springing, then you can't counter spring the weight of the slides, because if you try to counter spring the weight of the slides, it'll pop up when it's at the bottom. But instead, this system, what it does is every single individual slide is countersprung. So this weighs like 2 pounds, and all of the slides together weigh 2 pounds. So these 2 springs pull up with a force of 2 pounds to hold the mechanism. But then this one goes with 1.25, then 1.5. And at the very outside, it's a 2-pound force constant spring. So all of this allows every single one to be sprung individually, and it's extremely efficient because the motors only have to accelerate instead of fighting against gravity.
So what type of issues did you guys really face implementing? Because it's a very unique system the way you guys did it. So if you want to talk a little about how you actually made that happen in terms of implementing into the robot.
Yeah, so we did have some minor issues with sometimes where the counter springing would kind of unspool, but overall, we can avoid that happening just by mounting it carefully. And these springs kind of tension themselves when they go up, since that's what they're supposed to do. So all of this, even though we had some minor issues at the beginning, after working through it, these springs have been really good and reliable.
That's really cool. Now going a little bit into your hang mechanism. How does your hang mechanism work?
Yeah, so the hang mechanism, we didn't really want to add extra motors or that many actuators. So what we did was we rigged it onto the extension motors. So you can see here that the string is actually connected around a narrow part of our axle, so it's extremely high torque. This part, the extendo, is fast, but here it is high torque, and with less extension, we're still able to pull up and hang. Now these upper hooks are meant to grab onto the 3rd level bar. And what this will do is allow it so that our robot doesn't tip over when trying to hang and unbalance onto the ground. And so what it does is we have these 2 axons here, but the axons would slow down our slides during game. So in order to avoid that happening, we have a lot of slack, and we have the strings completely slack during the entire game, just managed by these zip ties and rubber bands so that they don't get tangled into any other mechanisms. And then at the end, the axons can start rotating and start pulling the slides down.
That's really cool. Now a little bit, how does your actual camera vision work, and how you actually made it work?
So the camera, we integrated it into our claw in a more recent design. What it does is it uses an open CV pipeline, and it detects the contours of all of the samples. We use YCRCB to do it, and it's worked pretty well for us.
That's really cool. Now, how else did you guys work and optimize your autonomous, and what programming challenges did you face throughout the season?
Yeah, so one of the main things we did is implement a state machine system so we can effectively track basically all of the different states our robot can be in at any time. And by doing this, we can track basically every single servo position as it is in real life. We also use motion profiling to smooth out movements, and some movements we want to do less aggressive than others because these Axon Maxes are really high torque and high speed. So having all of those systems together, we can really effectively plan out each and every action of a robot and have them execute one after another in the perfect amount of time.
And also talking a bit more about control, we have friction compensation on our robot. We implemented it. So what happens is that sometimes when making fine adjustments, the robot might get stuck by static friction. So to counter that, we have it so that if the velocity gets low, it essentially gives more power to the motors to avoid getting trapped in static friction. And also we're using the pinpoint this year. The pinpoint has been hugely helpful because the rate at which your odometry post tracker runs strongly determines how accurate it is. However, the pinpoint is like a separate processor, so it's constantly doing it, and we don't have to worry about dropping position accuracy even if we start something intensive like vision.
So your drivetrain really helped your season get to where it is today and the amount of excellence you guys achieved in your season. So if you want to talk a little bit about how it makes what's unique about your drivetrain for viewers to listen to.
Yeah, so this year, the unique part about our drivetrain is we do have a parallel plate chassis, but instead of belting it, we decided to keep it very simple as we had a lot of space and we're just direct driving 4 Gobilda 435 RPM motors, as you see here, and we still have space for all of our other subsystems.
Oh, that's awesome. That's really cool. Now, thank you for today's interview. This was Team 4215 Hypnotic Robotics, and congrats on your amazing season, and hope to see more from this team in the future.
Thank you.